Hi Year 12 Maths General students. This unit's from Unit 4 of the Queensland General Maths syllabus, and this lesson we're investigating investment schedules in annuities, and we're going to use recursion models and formula as well as Excel to investigate how we can compose investment schedules. We're also going to investigate the effects of varying different parts of the annuity, which includes like the amount you're depositing, the amount you're withdrawing, the interest rate, what happens if I make lump sum deposits, and other things. Alright, so investments can be tracked using payment schedules, very similar to when we looked at reducing loan schedules. And this can monitor the growth of an investment over time. The tricky thing with investment schedules is though that we have to consider deposit and withdrawal phases carefully. Whereas in reducing balanced loans, we only had to consider one phase of paying off the loan. We're going to start off by looking at the deposit phase and using an example where we've got an investment of $40,000 into an investment account that earns 3.5% per annum, compound interest, compounding monthly. Regular payments of $1,500 per month are also deposited. The payment schedule we see here below is a typical example of what a payment schedule would look like for an investment. So what we see here is payment number on the first column. Then you'll see that all the regular payments are deposits of $1,500. So you should be able to see that as time goes on, the interest you earn will increase in a deposit phase. Moving over to the principal change, this is how much your principal changes over the duration of the loan. So again, as we progress through time, you'll see that those amounts increase as well. And also common sense, because it's an investment situation, our balance increases. So you should see that during the deposit phase, as time progresses, the balance of the investment increases, the amount of the interest earned increases, and the principal added to the investment increases. You'll be expected to create these payment schedules using formula. So how do we go about doing this? Well, we can start off with our balances, and that's just using the recursion formula that we learned in last lesson. Once you've calculated the balance for each consecutive period, in this case we've got months, you can then pop in your deposits, which are going to be the same for every month. In this case, our interest earned, a quick way to do it is just the difference between the current month's balance and the previous month's balance, and then you minus the deposit amount. The principal change is therefore the deposit amount plus the amount of interest, which is all easily calculated. Let's now have a look at what happens when we change over to withdrawal phase of an investment, which means that we're changing over from depositing money to now withdrawing money from the account. So if we're considering the same scenario, in this case here, after the 4th month, we've changed to regular withdrawals of $800, and you can see that's made up until the 8th month. So having a closer look at this, our deposit phase you can see is in the first 4 months, and then we change over to withdrawal phase for the next consecutive 4 months. What I'd like to observe here is in our deposit phase, the payments stay the same, the interest earned increases, principal change increases, balance increases. However, when we move over to the withdrawal phase, you can see that the withdrawal payments are all the same. Our interest earned decreases, principal decreases, and our balance slowly decreases as well. Now you should see this during most withdrawal phases of investment as time progresses. So we're seeing the balance of the investment decreasing, the amount of interest earned decreasing, and the principal added to the investment decreasing. However, this is not always the case. If you're really smart about how much money you withdraw, you can still earn interest to maintain a balance in your investment or even increase the balance. And this is a maths concept called perpetuities, which we're going to look at in a little bit more detail later. So how do I calculate the values I need for an investment schedule when I have a deposit and a withdrawal phase? Well, you simply just need to switch over after you change phases. So for the deposit phase, we use the formula we saw above in the deposit phase. So for our balance, we use that annuities formula from the formula sheet. And then when we switch over to the withdrawal phase, we use that reducing balance loan formula. I would then put in your deposits or withdrawal amounts. The interest is therefore the difference between the current balance and previous balance. And in the deposit phase, you're minusing the deposit. In the withdrawal phase, you're adding on the amount you're withdrawing. For the principal change, for the deposit phase, you're adding the deposit to the amount of interest earned. In withdrawal phase, you're subtracting the interest earned from the amount you're withdrawing. Like I said, all of these formula come from what we've looked at in previous lessons using recursion formula and interest calculations we've learned. So just as a quick recap, these were the formula that we covered. So have a quick read over those to refresh your memories if you need to press pause. If we looked at the 4th and 5th month using all of those formula, we know that in the 4th month, we know that the balance was $44,864.16. We can work out the rate at which it's being charged interest because we know it's 3.5% and it's compounding monthly, and our regular deposits are $1,500. To get to the balance after the 4th month, we simply use that recursion formula to find the effect of the rate on the balance and add on that deposit amount to get our new balance for month 4. From there, I work out my interest by subtracting the two balances, and then I minus the deposit, and that gives me $130.85. And the principal change is therefore the deposit plus the amount of interest earned, which gives us a change in principal of $1,630.85. I do the same thing with the withdrawal phase. So I take that 4th month balance, I apply my rate and my withdrawal amount of $800. So you can see here to get my 5th month balance, I'm applying that rate to the previous balance, minusing that withdrawal amount of $800, and I end up with my 5th month balance. To work out the interest I've earned there, I simply find the difference between the two balances and add on this time the amount I'm withdrawing, and that gives me an interest of $135.61. Then lastly, my principal change is simply going to be the difference between the interest earned and the amount I've withdrawn. And thankfully my maths is good because that matches everything that we're seeing in the schedule. Okay, like we saw with the reducing balance loan schedules, it is a very time-consuming process to put one of those together. So to help us, we're going to use a bit of technology and visualize an investment payment schedule that I've put together on Excel. If you'd like to access this Excel, just check out the comments in the bottom of this video and you can download it for free and use it. Alright, so we're going to test what happens when you change different values within an investment schedule. So we're going to play around with a couple of things and have a look at the effects on an investment. So we're going to consider again our investment of $40,000 that earns 3.5% interest, compounding monthly. Regular repayments $1,500 per month, and this time we're going to deposit them until the 12th payment or after 1 year. We're going to change to a withdrawal phase of $800. So let's open up the spreadsheet and have a look at how it works. So it should be like this when you first open it. Everything's blank. You just need to enter in the relevant amounts. So we're starting off with a principal of $40,000. Because I'm an amateur Excel person, this is just built using my knowledge of formula. So it won't work properly until you put all of the investment details in. So 3.5% per annum monthly. We might just put it over 2 years. Regular deposit payment of $1,500. We want a payment withdrawal of $800, and we want that to start after the 12th month, so that means for the 13th payment onwards. Okay, you can see over here as well, there's a graph here that will help visualize what's happening to the balance of the investment over time. And please let me know if parts of it don't work properly. Like I said, I'm a rookie, so hopefully it works for any scenario that you can come up with. Okay, so you can see that over the first 12 months, the balance of the investment gets up to $59,714.25 before we start withdrawing money. And you can see as it progresses over the 2 years, the amount slowly dwindles. Now the graph continues to show you all the way down until it finishes, so it runs out of money. And we can play around and look for that by changing the values in here. So if I change this to 5 years, you'll see that it extends and there's still money after 5 years. If I change it to 10 years, let's have a look to see where it runs out of money. So around about the 97th payment, the 96th payment, I can still take $800 out, but then for the 97th withdrawal, I can only take out $243.09 before the account runs out of money. Okay, coming back to the example question, from A to E, we're going to change different things and see the effects on the investment. So part A wants us to calculate how much more we would have in the account if we increase deposits to $3,000 a month over the first year. So to check that out, I just simply change my payment deposit to $3,000. And you can see by that 12th month or year, that changes the balance to $78,005.83. So it's made a significant difference by doubling the amount I deposit into the account every month. So if I pop a little bit of a summary of what I saw there, the original investment details at that 1 year point, I had $59,714.25. And you can see there when the withdrawal began the effect on the balance visually. If I then have a look at the effect of increasing our deposits to $3,000 a month, you can see that it increased the balance to $78,005.83, which was $18,291.58 more than if I had only left the deposits as $1,500. Moving on to part B, what is the effect on the original investment scenario if we reduce the withdrawal amounts to $174.16 after the first year? And it says to keep adjusting this value until you find the point where the investment begins to lose money. So this is a very specific amount. So let's see what happens when we pop it in. Okay, so changing it back to the original deposit amount and then changing our withdrawal amount to $174.16. You can see what happens firstly in the principal change and the balance, as well as very visually on the graph. You can see that this has flattened out. Now, by taking withdrawals of that specific amount, my principal changes to growing by 1 cent every month. So you can see that I've kind of nearly reached that point where the investment will stop making money and start losing money. So let's play around with that a bit. If I change that to 174.18, now you can see that it's swapped over to now slowly losing money at 1 cent every month. and it's quite difficult to see on the graph, but it is slowly decreasing. What happens if I go in the middle of that? So 174.17 withdrawn every month. Okay, so it says that my principal is not changing at all. However, you can see that the balance is very, very, very slowly changing. And that just means that what we've got working here is fractions of a cent increase every month, which eventually accrue. So at this point, it's very close to that concept of perpetuities that I was introducing earlier. The point at which the balance of your loan can be maintained by controlling how much you withdraw from the account. Documenting what we saw there, we change the amount that we're withdrawing, and for that first amount we can see that the balance was just increasing by 1 cent. The next one we did was $174.18, so we're just decreasing by 1 cent. And then lastly, that point that's very nearly near the point of perpetuity, which we'll look at in another lesson. Okay, just moving down to C, if we're considering the initial conditions again, so change everything back, calculate how much more you would have if you change the compounding period to being fortnightly instead of monthly over the first year. Okay, so popping back to our spreadsheet, we need to change this to minus 800 again. Now, if we change the payments per year, we've got to change that to 26 to be fortnightly, which also means that we want to change the payment withdrawal to start after that whole year. So that means we want that to start on the 27th payment. So you can visually see the effect on the balance. It's whacked it right back up again. And if I have a look, my balance after that year is $81,087.19, and you can see that it runs out of money on the 136th fortnight. Okay, so if I just document what I saw there, the 26th payment, which is 1 year, that gave me a new balance of $81,087.19, which is $21,372.94 more than my initial conditions. Moving on to part D, considering the initial conditions again, calculate how much we'd earn after 1 year if we put in lump sums now of $10,000 in addition to the regular monthly payments. And we're going to put it in, try it at 2 months, then we're going to reset it and try the lump sum after 6 months. Okay, so if I change the conditions back to how they were, we're going to put in a lump sum after the 2nd month, so that means on the 3rd month. So 10,000 plus the 1,500 gives us 11,500. Okay, and if you change something in this spreadsheet, don't forget to change it back because these have formula. Hopefully you'll see the increase in the balance up to $69,979.84. You'll also notice the shape of the balance changes. So you can see here, this is where we popped in our lump sum, which boosted the balance. Okay, let's change back that 3rd month to what it was. You can do this just by Control-Zing or dragging up that green square. Now we're going to look at what happens when we change it at that 7th month. Okay, so checking our year balance again, that puts us on $69,860.94. And you can see the effect on the graph, it's just shoved over that boosted part of the balance. So hopefully what you've noticed there is that the sooner we put in our lump sum, so if we put it in at the 3 month compared to the 7th month, our balance very logically will also increase in the investment. So just documenting that, our initial scenario had a balance of $59,714.25. After we popped that lump sum in, that boosted our balance, 1 year balance to 69, nearly 70,000, which is $10,265.59 more. If I have a look at the 7-month lump sum deposit, that boosted our balance by $10,146.69 more. Okay, lastly, we want to compare the balance after a year if we increase our interest rate to 4.2% per annum, compounding monthly, considering the initial conditions. So if we pop back here, we're changing our interest rate to 4.2 and checking out what happens to the balance. So after 12 months, we have a balance of $60,063.29. Okay, so checking the effect of that, how much more? If our new balance is $60,063.29, that's a whole $349.04 more. So the interest rate increases the investment, but not as significantly as things like increasing your payment deposit amount or the number of compounding periods that you choose your investment to be under. Just from looking at that example, you should notice that the best growth in investment will occur when you choose an investment that has more compounding periods per year. You can increase the amount of money you regularly deposit, and the earlier you do this, the better. You can make extra lump sum deposit payments, and the earlier the better. Look for the highest interest rate around, but this won't have the same significant effect as extra deposits or more compounding periods, but it does make a difference to your money growing. The longer you continue your deposit phase, the better. And the cool thing about these investment schedules is if you play around with the amount you withdraw, you can identify the perpetuity of the investment. And this will mean that you can maintain or even still grow the balance on your investment. So that's like money for life if you can manage your investment that way. Okay, I would like you to try some examples for yourself now. I've put 3 example questions there for you to try. So have a look through them, read the information in them very carefully. I'd like you to, where you can, make sure you're practicing doing these calculations by hand, unless the question says to use the spreadsheet. This should take you probably about half an hour to 40 minutes to do these 3 questions. So press pause, have a go at the 3 questions. And then check in to see how your answers compare to mine. See how you went with question 1. So we've got Jasmine, who invests $30,000 into an investment account, earning 4.2% per annum compound interest every month. She also makes regular deposits of $1,200. You have to construct an investment payment schedule over the first 4 months of the investment. Part B asks you to calculate the total interest. Then Part C gets you to use that investment payment schedule spreadsheet to help firstly check the details that you've put together for Parts A and B are correct. Then look at the total amount Jasmine would have in her account after 2 years. And then the last part is looking at if she needs to withdraw regular payments of $600 after the 10th month. So that means the withdrawals begin in the 11th month. She needs to pay off her car repairs for 6 months. We want to know what the balance on her account is after that 6-month period. Alright, so hopefully when you come to the question, you're always annotating the question, pulling out those important bits of information. When we look at the answer for A, hopefully your payment schedule looks something like mine. I've just popped in the headings there, the formula I used to calculate those values. For part B, the total interest, you can use the formula we learned in the previous lesson. However, it's super simple just to add up the total of those 4 months interest worth to get $447.47. For part C, We're just putting together that investment schedule to check that the amounts we have are correct. So you can see that matches what we did by hand above. And for part 2, we want to know the balance after 2 years, which was $62,613.59. So that's just during a deposit phase. After the 10th month for part 3, we're entering into a withdrawal phase at the 11th month. So at the end of 6 months after that, so we're into the 16th month, the balance would be $40,542.21. So it's eaten into her investment savings. So just remember, if you're ever asked to do this in an exam question, for the withdrawal phase, you can work out the balance just by using your recursion formula on your calculators. So just a quick reminder on how to do that. You'd put in your balance. You press equals to store it. You multiply it by the rate. And withdraw 600 each time. So that way the calculator will apply that formula to your next balance. So you can see first month, second, third, fourth, fifth, 6 months of withdrawing $600 manually done by calculator. Okay, question 2, we were given a investment schedule. The first part we had to do was find the missing values within the schedule. So A is just still in deposit phase, so the payment must still be $2,000. For B, the principal change, remember, is simply the deposit amount plus the interest earned. So that gives us the B value. For C, we simply want the difference in balance, previous balance to current balance. And then because it's a withdrawal phase payment, we add on that to get the interest earned, which will be $161.79. And for D, subtract the principal change from the previous balance to end up with our new balance of $83,531.23. For part B, we wanted to print out the 19th month worth of values. So if I generate those values, hopefully your 19th month looks like mine. This one was a bit tricky because before you could actually calculate the next balance, you needed to evaluate what the rate was for the formula. So we did a bit of working backwards to work out what the rate was. So using that recursion formula, if we plug those values in, we just need to solve for R, work backwards to get an R of 1.00192. For part C, using the investment schedule, if the principal is $55,000, which month does the investment account change phase? Well, we saw that happened in the 14th month. So it went from deposits of $2,000 to withdrawals of $600. Part 2, determine the annual percentage interest rate. So if we've figured out what R is, again we can work backwards and work out our interest rate using that formula. So I got an interest rate of 2.3% per annum, which when I plug it into my spreadsheet, it generates values that match the spreadsheet that I got given. And then if I want to check my solutions for all the parts so far, there's my A, there's B, there's my C, and my D. and the 19th month balance. All these details look correct. For the third part, if a lump sum repayment of $6,000 was made in the 10th month and the change in withdrawal phase left until the 30th month, determine how much more would be in the account after the 60th month. Okay, so we've made a lump sum deposit of $6,000 on top of the normal repayment in the 10th month. Okay, and just a note before the changes, hopefully when you put all those values into your calculator, you'd see that the original balance was $63,833.91. When I pop in that additional 6,000, that means I'm putting in 8,000 into the 10th month. You're then, because it says withdrawal phase until the 30th month, so that means on the 30th month we change the withdrawals to be $600. So then after the 30th month, if you scroll all the way down to the 60th month, we see a balance of $112,381.77. So that's reinforcing leaving the deposit phase for longer will increase your investment, as well as making a lump sum deposit in your account. Okay, lastly for part 4, considering the initial conditions of the investment again, determine how much would be in the investment after the 60th month if the withdrawal amount was reduced to $500, so reducing the amount we take out. So comparing the two balances, you'd see that there's $4,804.07 more. Lastly, for question 3, we've got Sigourney shopping around for a superannuation fund after she's been unhappy with her current one. She's got $150,000 that she's bringing over, and she's got 10 years before she retires. Her employers make contributions of $570 a month, and because we're considering two funds that have different compounding interest terms, so let's look at Superannuation Fund A. That's 2.6% per annum paid quarterly. Superannuation Fund B has interest of 2.3% paid monthly. After 10 years, she hopes to draw income of $4,000 every month, or equivalent if we're talking about quarters, until the money runs out. And you're going to use the investment spreadsheet to do that. Would definitely not expect you to do this question by hand. It would take you way too long to do all those recursions. Pulling apart that information and popping it into the spreadsheet. 10 years for Super Fund A means we're talking about 40 quarters. Because we've been given values monthly, we need to change them into quarterly. So that means those deposits that are being made are $1,710 and withdrawals are $12,000 a quarter. Okay, so if I pop those values in and scan all the way down my spreadsheet, on the 65th quarter, the money will run out. So you can see that this money will last her 6 years and 3 months. You'll also notice that the balance she's accrued is $272,204.41. If I compare that to Super Fund B, so that's in monthly, so my deposits are $570, my withdrawals are $4,000. So you can see that around the 192nd month, the money runs out. So if I translate that into years, it's a bit easier to think about. That's only 6 years. So considering those two options, I would recommend that Sigourney goes with Superannuation Fund A, the 2.6 per annum compounding quarterly, because she has a higher balance at the 10-year mark and it lasts 3 months longer. Okay, hopefully this has given you a better understanding of the deposit and withdrawal phases of an investment And by changing different values in your favor, you can increase the growth of your investment. So remember, they include choosing an investment that has more compounding periods per year, increasing the amount you deposit. The earlier you do that, the better. If you can make any extra lump sum deposit payments, the earlier you do this, the better. Look for a high interest rate. This will also help grow your money more. And the longer you can continue your deposit phase, the better. And if you're smart about it, you can work out a perpetuity of your investment, where if you keep the amount you withdraw equal or below this particular value, you will always maintain your balance or even grow your balance. Money for life. Thanks, Year 12s.